Hello everyone, my name is ASTRONOMER'S and today we are going to talk about Earth. Introduction. Our home planet is the third planet from the Sun and the only place we know of so far that's inhabited by living beings. While Earth is only the fifth largest planet in the solar system, it is the only place in our solar system with liquid water on the surface. Just slightly larger than nearby Venus, Earth is the biggest of the four planets closest to the Sun, all of which are made of rock and metal. The name Earth is at least 1000 years old. All the planets except for Earth were named after Greek and Roman gods and goddesses. However, the name Earth is a Germanic word which simply means the ground. Size and distance. With a radius of 3,959 miles, Earth is the biggest of the terrestrial planets and the fifth largest planet overall. From an average distance of 93 million miles, Earth is exactly 1 astronomical unit away from the Sun because 1 astronomical unit is the distance from the Sun to Earth. This unit provides an easy way to quickly compare planets' distances from the Sun. It takes about 8 minutes for light from Sun to reach our planet. Orbit and rotation. As Earth orbits the Sun, it completes one rotation every 23.9 hours. It takes 365.25 days to complete one trip around the Sun. That extra quarter of a day represents a challenge to our calendar systems, which count 1 year as 365 days. To keep our yearly calendars consistent with our orbit around the Sun, every 4 years we add 1 day. That day is called a leap day, and the year is added to is called as leap year. Earth's axis of rotation is tilted 23.4 degrees with respect to the plane of Earth's orbit around the Sun. This tilt causes our yearly cycle of season. During part of the year, the northern hemisphere is tilted towards the Sun and the southern hemisphere is tilted away. With the Sun higher in the sky, solar heating is greater in the north, producing summer there. Less direct solar heating produces winter in the south. 6 months later, the situation is reversed. When spring and fall begin, both hemispheres receive roughly equal amounts of heat from the Sun. Structure. Earth is composed of 4 main layers, starting from an inner core at the planet's center, enveloped by outer core, mantle, and crust. The inner core is a solid sphere made up of iron and nickel metals about 759 miles in radius. There, the temperature is as high as 9800 degrees Fahrenheit. Surrounding the inner core is the outer core. This layer is about 1400 miles thick, made up of iron and nickel fluids. In between the outer and crust is the mantle, the thickest layer. This hot viscous mixture of molten rock is about 1800 miles thick and has the consistency of caramel. The outermost layer of Earth's crust goes around 19 miles deep on average on land. At the bottom of the ocean, the crust is thinner and extends about 3 miles from the sea floor to the top of the mantle. Formation. When the solar system settled into its current layout, about 4.5 billion years ago, Earth formed when gravity pulled swirling gas and dust in to become the third planet from the Sun. Like its fellow terrestrial planets, Earth has a central core, a rocky mantle, and a solid crust. Surface. Like Mars and Venus, Earth has volcanoes, mountains, and valleys. Earth's lithosphere, which includes the crust and the upper mantle, is divided into huge plates that are constantly moving. For example, the North American plate moves west from the Pacific Ocean basin roughly at a rate of equal to the growth of our fingernails. Earth's global ocean, which covers nearly 70% of the planet's surface, has an average depth of about 2.5 miles and contains 97% of Earth's water. Almost all of the Earth's volcanoes are hidden under these oceans. Hawaiian Mauna Kea volcano is taller than base to summit than mountain Everest, but most of it's underwater. Earth's longest mountain range is also underwater. At the bottom of the Arctic and Atlantic Oceans, it is 4 times longer than Andes, Rockies, and Himalayas combined. Atmosphere. Near the surface, Earth has an atmosphere that consists of 78% nitrogen, 21% oxygen, 1% other gases such as argon, carbon dioxide, and neon. The atmosphere affects Earth's long-term climate and short-term local weather and shields us from much of the harmful radiation coming from the sun. It also protects us from meteoroids, most of which burn up in the atmosphere, seen as meteoroids in the night sky before they strike the surface as meteoroids. Magnetosphere. Our planet's rapid rotation and molten nickel iron core gives rise to magnetic field, which the solar system distorts into a teardrop shape in space. When charged particles from the solar wind become trapped in Earth's magnetic field, they collide with air molecules above our planet's magnetic poles. These air molecules then begin to glow and cause aurora, as seen in the northern and southern lights. The magnetic field is what causes compass needles to point to the North Pole, regardless of which way you turn, but the magnetic polarity of Earth can change. Flipping the direction of the magnetic field, the geological records tells scientists that a magnetic reversal takes place for about every 400,000 years on average, but the timing is very irregular. As far as we know, such a magnetical reverse does not cause any harm to life on Earth, and the reversal is very unlikely to happen for at least another 1,000 years. But when it does happen, compass needles are likely to point in many different directions for a few centuries before the switch is being made, and after the switch is completed, they will all point south instead of north. This is an example of the magnetosphere of our Earth. Moons. Earth is the only planet that has a single moon. Our moon is the brightest and most familiar looking object in the night sky. In many ways, the moon is responsible for making Earth such a great home. It stabilizes our planet's wobble, which has made the planet climate less variable over thousands of years. Some moons are bits of rock that were captured by the planet's gravity, but our moon is likely the result of a collision billions of years ago when Earth was a young planet. A large chunk of rock smashed into it, displacing a portion of Earth's interior. The resulting chunks clumped together and formed our moon. With a radius of about 1080 miles, the moon is the fifth largest moon in our solar system. The moon is farther away from Earth than most people realize. The moon is an average of 238,855 miles away. That means 30 Earth-sized planets could fit in between Earth and the moon. This is the picture of moon clicked by me. Potential for life. Earth has a very hospitable temperature that is a mix of chemicals that have made life possible here. Most notably, Earth is unique in that most of our planet is covered in water, since the temperature allows liquid water to exist for extended periods of time. Earth's vast oceans provided a convenient place for life to begin about 3.8 billion years ago. Some of the features of our planet that make it great for sustaining life are changing due to ongoing effects of climate change. Fun fact 4. Tectonic plates keeps the planet comfortable. The Earth is the only planet in our solar system with plate tectonics or tectonic plates. Basically, the outer crust of the Earth is broken up into regions known as tectonic plates. These are floating on top of the magma interior of the Earth and can move one against one another. When two plates collide, one plate will subduct or go underneath another, and where they will pull apart, they will allow fresh crust to form. This process is very important and for a number of reasons. Not only does it lead to tectonic resurfacing or geological activity, it is also instructive to the carbon cycle. When microscopic planets in the ocean die, they fall to the bottom of the ocean. Over long periods of time, the remains of the life rich in carbon are carried back into the interior of the Earth and recycled. This pulls carbon out of the atmosphere, which makes sure that we don't suffer a runaway greenhouse effect, which is what happened to Venus. Without the action of tectonic plates, there would be no way to recycle this carbon, and Earth would become a overheated hellish place just like Venus. Thank you for watching this video. Please subscribe and like to my channel.